Okay, now let us look at the solution of the given problem. So let us look at the second one. So what you need to do is you need to expand the LHS here, as you can see. So multiply x into x plus x into 2. So what would this give? X into x at x square, x into 2, that's 2x, equals to x square plus 3x plus 5. So whatever is on the RHS, just bring it to the LHS. So you have x square plus 2x minus x square minus 3x minus 5 equals to 0. As you can see, x square minus x square goes away. Now what is this? Minus x minus 5 equals to 0. So let us make this minus, let's change this to plus. So what we need to do is you just need to multiply this by minus. So x plus 5 equals to 0. Now as you can see, is this a quadratic equation? This is not a quadratic equation because there is no x square term, right? A should not be equal to 0. So you don't have a x square term, so this is not a quadratic equation. But let's say if you're not worried about the simplification, if you just look at the first line, it seems that it's a quadratic equation, right? Because there's an x square term involved here. But actually the x square terms gets cancelled from the LHS and RHS. So that's why we need to simplify first and reduce it to this form. Then only we should take a decision like whether it's a quadratic or not. So in this case, this is not a quadratic equation, it is actually a linear equation. Let us look at the third one. So what you need to do, you just need to use a plus b whole cube formula. So if you use the formula, what you get? X cube plus 3x square plus 3x plus 1 equals to x cube plus 5. Now RHS, bring it to the LHS. So that would be negative. So x cube plus 3x square plus 3x plus 1 minus x cube minus 5 equals to 0. As you can see, x cube and minus x cube gets cancelled. You are left with 3x square plus 3x minus 4 equals to 0, right? So is this a quadratic equation? Yes, it's a quadratic equation. What are A, B, C? A is 3. What is B? B is 3. What is C? C is minus 4. Now it seems that from the first line, it seems that it's not a quadratic equation, right? You might look here x cube. The degree is more than 2, right? You might seem that it might seem in that way, but actually the thing is x cube term gets cancelled, so I left with the x square term. So therefore this is a quadratic equation. What about the fourth one? So what you need to do is you need to simplify this. So expand this. So you have x plus 1 in the LHS. So this would be x square plus 1 plus 2 times x plus 1 into 2, that's 2. So you have x plus 1 equals to x square plus 3x plus 2. Bring everything to the LHS. X plus 1 minus x square minus 3x minus 2 equals to 0. So you have minus x square. So I am just writing in this form. Minus 3x plus x, that gives minus 2x minus 1 equals to 0. So what you can do is you can either make the x square term positive. So this becomes x square. So what I am doing is I am just multiplying the whole equation by minus 1. So x square plus 2x plus 1 equals to 0. So in that case, what is A? A is 1. What is B? B is 2. What is C? C is 1. Is this a quadratic equation? Yes, this is a quadratic equation. So what you need to do is, if you get an equation, just ensure that the equation is expanded and simplified before taking any decision. And once it is simplified, like once it is the RHS is 0 and once everything is simplified, just check whether it is of this form or not. Once it is of this form where A is not equal to 0, you can say it's a quadratic equation. So in this case, for example, in this case you might think that it's a quadratic equation, but actually it's a linear equation. You might think that it's a cubic equation, but it's a quadratic equation. So first you have to simplify and then only say whether it's a quadratic equation or not.